Good day, grade 11 chemistry students. Today what we're going to do is learn how to draw Lewis structures, Lewis dot diagrams as well, and predict ionic charge. Well, first of all, what is an ion? An ion is an atom with a different number of electrons than protons. Now recall, this means that the atom will actually have an overall charge. Now remember that atoms are made up of protons, have a positive charge, have a mass of 1, electrons, which have a negative charge and no mass, and neutrons, which have no charge and have a mass of 1. So when you have the same number of protons as electrons, you are a neutral charge. So if you have 4 protons, 4 electrons, no charge. But if you have a different number of electrons than protons, then suddenly you have a charge. So this column here is going to represent protons, this column here is going to represent electrons. If you have 1 proton and 1 electron, you have no charge. If we add another electron, recall that this little charge here means it's negative. I now have 1 plus and 2 negative. That means my overall charge is going to be negative. We call negative charged atoms, we call them anions. Okay, so when you are negative, you are a special type of ion called an anion. When you have, let's say for example, let's say we had 2 protons and we had 1 electron, that means we would have a 1 plus charge. Positive ions are called cations. So what we're going to do today is we're going to talk about how to draw Lewis structures, Lewis dot diagrams, and then we're going to talk about how to predict the charge that they will form. So let's look at the periodic table and let's determine how to draw the Lewis dot diagram. Now, one way you could draw the Lewis dot diagram is by doing all the Bohr-Rutherfords and then seeing how many valence electrons they have in the outermost shell, and then just drawing the element symbol and then drawing out the Lewis dot diagram. For example, lithium, again, I could draw out the Bohr-Rutherford and determine it, and then draw the Lewis dot diagram, which is just the symbol with a valence electron on the outside. But there's actually an easier way. The group number will actually tell you how many valence electrons each one has. So again, actually, let's skip all those guys in the middle. And we're going to go here. And this is actually, you'll notice it says A's below there. It says 3A, 4A, 5A, 6A, 7A. This tells you how many valence electrons each group has. So you have 1 valence electron, 2, 3, 4, 5, 6, 7, 8 right there. So this means that by looking at anybody in one of these groups, you can tell how many valence electrons it has. For example, arsenic, it's in group 5 or 15, group 5A, it has 5 valence electrons. So we can draw that out. So with the Lewis dot diagram, we have to put 5 valence electrons around. We know that the first shell holds 2. Arsenic is way down the periodic table, so that means it's going to have 8. So we half fill before we pair. So we go 1, 2, 3, 4, north, east, south, west, and then we pair. It doesn't really matter where you pair as long as you have 1 pair there. These guys are bachelors, these electrons here, and they're going to be looking for pairs on their own. So electrons are not stable when they are not in a pair. That's why I've pointed an arrow to these. Now this has 5 valence electrons. So when arsenic wants to become an ion, if it's gonna gain or lose electrons, it wants to become stable. So let's imagine what we could do if we made it stable. We would add 3 more electrons. Now recall, if I add 3 more electrons, electrons are negative. So if I add electrons, I become negative. And if I become negative, that means I'm going to become an anion. Now this is stable now when we add, stable when we add these 3 guys here, because it has a full shell and it's now stable. Okay, so what we want to do is we want to determine what charge it has. Well, what's the charge of these 3 negative? I now have 3 more electrons than I do protons. Recall when I drew this out that originally that I had the same number of protons and electrons, but when I add these 3 electrons, I actually have a negative charge. So arsenic is an anion, again, with a negative 3 charge because it gained 3 electrons. So when we look at arsenic, it's got 33 protons and 33 electrons when it is a neutral atom. So when it was neutral, it had 33 protons and 33 electrons. We knew in group 5, because it was in group 5 or 5A or 15, group 5A, it had 5 valence electrons. And we knew that if it's going to become stable, it's going to gain 3 electrons. It's a lot easier for it to gain 3 than to lose 5. So then it went to a count of 36. And you should have remembered by now 36 electrons and 33 protons. If you add these numbers together, you would get 3 negative. So arsenic becomes 3 negative. And what we do is we show it now with a full shell. We put a bracket around it. We only do this for the negative ones. And it's got a 3 negative charge. So let's talk about calcium. What about calcium? What's going to happen with calcium? Well, we know if we're going to draw this, we have to put a Ca here. And then we have to know how many valence electrons it has. So we find it on the periodic table. So we look at calcium, we see it has the number 20. We also see that it's in group 2 right here. Now because it has the atomic number of 20, that means it's got 20 protons. When it's neutral, it would have 20 electrons. I really don't need this information to draw the Lewis dot diagrams, but I'm just keeping track of it. I know it's got the atomic number of 20 electrons, it was neutral. We know it's in group 2, so therefore we know it's going to have 2 valence electrons. Now we don't put these 2 valence electrons right beside each other because it's not the first shell. Calcium is actually way down here. It actually has 4 shells, so it would have 2 valence electrons, 8 valence electrons in the second shell, 8 in the third shell, but in the fourth shell, it's in group 2, it would have 2 valence electrons. So here calcium is with its 2 valence electrons. It is neutral. It is neutral because it has 20 pluses and 20 negatives, but it is not stable. And it's not stable because it doesn't have a full shell. So what's this atom going to do to get a full shell? Is it going to gain 6 electrons and then it would have a full shell? Or another thing it could do is just remove these 2 electrons. Now some of you guys are like, well, it doesn't have any electrons then. Well, yes, it does. It now would go from 20 electrons to 18 electrons. Those electrons would sit in underneath these 2 electrons, and they would have the first 2 would go in the first shell with 2 electrons, the next shell would have 8, and that last shell would have 8 as well. So that's 2 plus 8, which is 10, which is 18. So it would have a full shell at this point. We show it like this. We say calcium has a 2 plus charge. We don't put any valence electrons around it. We say that it lost its outermost valence electrons. It is now stable. This is a cation. Cations are stable, but they have an overall charge of +2, and that's because it has more protons. Okay, I'm going to pause this and take a moment and look at gallium right here. This is gallium number 31. How many valence electrons does gallium have? Is it going to gain or lose electrons to become an ion? Will it become a cation when it loses it, or will it become an anion when it gains electrons? Draw the Lewis dot diagram and then determine what type of charge and ion it will form. Gallium is in group 3, so therefore it will have 3 valence electrons. None will be paired because this is a shell of 8 because it's not in the first shell. And it's none, again, you'd have to half fill before you pair. So this is going to become a cation because it has less than 4 electrons. And it will lose all 3 of these. And when it loses these electrons, it loses 3 negative charge. And that means it's no longer neutral. It has 3 more protons. It will get a 3 plus charge. It will become a 3 positive charge cation. And that ion, that cation, is now stable, but it has a charge when it loses this 3. That's it for now, folks. Hope you enjoyed the lesson. See you tomorrow.